Hi guys, welcome to Pixel Affair. It's Kobe here. So in today's video we are going to talk about Cinema 4D's standard particles and how to get our particles to move along a line or follow a path that we draw using a spline like we have in this video playing in the scene, right? So this is a technique that we can actually use a couple of ways to do it, but in this video I'll show two different ways of doing the same or similar technique, right? So I quickly rendered this scene which I have here, and if I hit play you can see I quickly did a quick render, not high resolution, but you can see particles moving from one container into another, right? And you can actually even mesh it to get something like a liquid moving from one container to another, which I probably will do in another video. But let's go ahead and see how we will actually create these particles and use these two techniques to get our particles to follow a spline. We are going to use one, forces of Cinema 4D, and two, you use a deformer and mograph. So let's get into a new scene and see how we will do something like this. So I have a new scene here and I'm using Cinema 4D 2024.2, right? So all I have in the scene is these two containers, which I actually grabbed from the asset browser here, and also a spline, which you can simply take the spline to and quickly draw any kind of spline that you want. Let's undo this. All right, so Control Z, all of that. So now this is all I have in the scene. So all we want is our particles, create a particle, and we want it to follow the path. Now, like I said, you are going to use two different techniques, right? So the first technique I'm going to show is using the normal Cinema 4D forces to get the particles to follow this path. So first of all, let me hide these containers and let's see the end and the beginning of the path, like the spline. And let's go into our simulation tab here and create our particles. So I come into simulation, emitter, and I create my emitter, and I want the emitter, if I hit play, you can see the particles are going on the Z direction. I want the particles to move from this point A to this point B. So to use the Cinema 4D forces, let's get our emitter closer to the point where we want it to start, right? So now I'll select my emitter and I'll move it closer to this point somewhere here. I'll rotate it a bit, like 90. All these are really not necessary, but I mean it makes it a bit more efficient, so I'll make it 90 and make it a little bit smaller, right? You can select the emitter itself and do all these changes like in the emitter tab here. You see, make it 45 centimeters by 45 centimeters. You can actually make it whatever size you want, but this is fine for now. And let's also increase the particles to something like 1000, because we can. In fact, I'll move the emitter a bit downwards like that. And now if I hit play, you can see our particles are going upwards, but we want it to follow the path, right? And how do we do that? It's as simple. So you come back into the simulation tab, into the forces, and you will create a field force, right? So with the field force, which I think was introduced in Cinema 4D R21 or so, right? We create a field force, and like I said, we want it to follow the spline. So in the select the field force, come to its attributes, and in the object tab, you can see we have this space here. We drag and drop our spline in here, right? And you can see some vectors are showing in the scene, but for now let's ignore it. Let's first of all change the velocity type from add velocity to set velocity, absolute velocity, and also increase the strength to something like 150. So what it's going to do is that it's going to give our particles the direction and also its velocity or its speed, right? So what this particle the speed in here doesn't really matter at all. See the particle speed, it doesn't matter. So if I hit play, you can see something is happening. Our particles are generating, but it's not moving. And that's because if I select the field force and come to select the spline in the field force here and come down here to the tabs under, you can see you have direction and it's saying use value, and that's because the value as it stands now, it's like sort of along the spline. So I think the strength is more on this side than this particular side. That's how come it's not moving, because we have our emitter here. So we want our strength to be like wherever the spline is sort of be around there. So we have to change the direction from use value to normalize, and now wherever our spline is sort of, it gives our in normal everywhere like our emitter is basically respect the spline. So if I hit play now, you can see now our particles are following the path of the spline, with which is exactly what we want. Let's increase our number of frames to something like 600, right? And I can see our particles are following exactly how we want it, which is fine. But what we want is that we want a bit of variation in the movement, everything like a bit of turbulence, right? So to do that, first of all, I'll actually um, hide the field force. I don't like the lines showing in there. So if we hit play, you can see it's following, but everything is clean and following perfectly. So I want a bit of turbulence in there. So I'll come into the simulation tab, forces again, and I'll add turbulence. And if I hit play, not much is happening. So let's select the turbulence. Let's drag it down. Select the turbulence, increase the strength even to like 200 if you want, and also increase the scale to maybe 41, something like that. If you hit play, you can see now there's some random movement in it, but it's going sort of haywire everywhere, right? And we want, in as much as we want turbulence in it, we want it to stay within some limits. Don't want it to go all over the place. Like you can see somewhere, some are all over the place and everything. But I want some turbulence in it, but stay within a certain radius, right? So to do that, within the turbulence, we come to the field tab. Let's drag and drop the spline in here and select the spline. Come down to the distance mode and change it to radius, right? And now let's set the radius to something like I think 55 will be fine for now. Let's check and see. If we hit play, you can see we have some turbulence in it, but it's not going all over the place. It stays within a certain radius, and something, this is something that is fine for now, right? Now, like I said, if I bring back our scene, you can see we want it to move from this container into this particular cap, but there's an issue when it gets here. Because of the turbulence, some of them overlap, like passes over the cap and go outside the cap. But we want everything, when it gets to this particular point, everything to sort of shrink together, like come together, and all of it fall within the cap, right? So if I hit play again, you can see everything is coming, but some go above the cap. Another thing is that we don't want, when it gets here, we want our particle to sort of disappear. So that's if we select our emitter and come into the particles, the lifetime, the particles can last. Let's check. If we hit play, and I think at our frame 120, our particles have lived their life. So let's set particles life to probably 110 and add a little bit of variation, like 10% variation. So let's see if we hit play, particles come. I still think it's going overboard, so you can even set it to 100, right? And now if we hit play again, our particles follow the path, and now somewhere here it disappears, which I think is fine. Now, like I said, we don't want it to go over like all over the place. At this point, we want it to sort of all of them come together right at the tip here, so that like it all falls within the cap and some don't go out over the cap. So to do that, we will use another field force. So let's so this field force, let's name this one, is for following the spline. So I'll name it follow spline. And now let's create another field force to sort of attract the particles when they get to this point, right? So I'll come into the simulation forces and I'll create another field force, drag it down, and I'll name it attract, right? So with this field force, let's drag in the spline once again. We will select the spline, and instead of the mode, we change it, instead of along, we change it to radius, right? And let's also come up, not actually, you see what, another thing you have to check is that make sure when you are dragging your spline, make sure you drag it into the object tab here, not the field tab, right? So let's delete it, this one for now, and come to the object tab rather, and let's drag in our spline, right? Select the spline and make sure the radius, come to the layer tab here and make sure the distance mode is set to radius, right? And also the same thing, let's change the velocity type from add velocity to set absolute velocity, and let's increase its strength to something like 60. And now the radius that we want, so let's I think the radius something let's see 30 for now and see if we hit play. um you can see something is happening if we disable the turbulence. And let me hide our scene object and hit play. Also, one thing we have forgot to do is we have to select the spline, remember the direction, and change it so that it respects like the spline wherever it is. So let's change it from the length to use value to normalize, right? And let's also hide this one as well. So now if we hit play, you can see instead of it attracting it, it's sort of pushing it away. You can see what's happening, right? So in the normalize, let's invert the direction. So invert direction in the normalize, and you can see now it's pulling it all along the spline right from the beginning. And that's not what we want. We want it to happen somewhere down here, right? So in the beginning, you want everything to follow, like move normally and get into the end, it starts pulling it together. So how do we do that? We use fields. So within the field force at, attract, we come into the field and let's drag in the spline once again. And now this time, if we hit play, let's see what happens. You can see nothing happens, but whilst it gets closer, it's getting here, it starts attracting it. But we don't want it to attract it this quicker. So select it, the spline here, come to the start range, and let's push it forward a bit. And now you can see now it starts attracting it somewhere here. So let's push it a bit more. Let's also select our emitter and increase the number stop emission to like 500. So our emitter will emit till frame 500, and now you can see this is where it starts pulling it together. If we think we want it to pull more, we can actually move it. So now if I bring back as you can see now at this point, everything comes together and falls into our cap. Now if I enable the turbulence and bring this back, you can see everything will move, but when it gets there, it all sort of pulled it together, right? So we can play around with it, so eventually we get something which is fine. So let's go back to the attract. I think some still gets away here, so let's push it back a bit. And now basically everything, you know, gets in smoothly, right? So you can play with it so you get something nice. So that's basically what you would do. So from here going, you basically go ahead and add extra forces to get the kind of shape that you want, and also increase the number of particles. So now I can set it to like say 10,000 by 10,000, right? So this is one way that you do this particular effect, right? And you can see everything is working fine, exactly, right? So now let's go to the second technique, right? This is basically how I did the first scene that I showed, which was playing. But what I did is that I created a couple of emitters. So I grouped all of these particles together. So for instance, I create a null object and make sure all of these are in it, right? Another thing I did is select the emitter, include, and the forces I make sure this one is set to include, and I drag all these forces. So what's happening is that this emitter can be affected by only these forces, right? So now if I hold control and create another copy of this scene, all these forces will affect only the one within this particular null. So if I select this one, for instance, and name it like field force attract to turbulence 2, you can see if I select the emitter and come in here, you can see that are the only forces that will affect this particular emitter, which is the emitter 2, right? And I give this a bit of variation, like the particles and the speed, and change the seed and all of those things to give it a bit of variation. So that's basically what I did with this particular scene, right? Now let's actually show the other way to do it using mograph like in Deformer as well. So I create a new scene and you're going to use the same emitter. So you come into a simulation emitter, you create an emitter, and now let's actually for now set the emitter size to like we did maybe 40 by 40, right? And if you hit play, you can see our particles are generating. Let's increase the number of particles again to like 1,000. And the speed doesn't matter in this case, so you can set it to 0. Now we will need the field force once again. So now I'll select, come to simulation, um, forces, and I'll create a field force. This time you're not going to use the spline directly. So we select the field force. And with the field force, when you use, you can actually use fields in it. So I can select the linear field and change its direction to maybe plus Z. And if I hit play, let's actually select the field force here. Make sure R to velocity is changed to set absolute velocity, and let's increase it again 150. And now if I hit play, it should be moving. I don't know why. Set absolute velocity. Oh, actually, so another issue problem is that I actually added the field inside the its fields. Actually, should be added in here, the object tab. So let's delete this and come to the object tab. This is where you should add the linear field. So now if we set it to plus Z and hit play, you can see it's pushing it away. You can change it to X and you can push it on the X, Y, and you push it upwards. But in this case, the plus Z is fine. So that's what exactly we want. So this is going to basically, we are going to use the field force and the turbulence and all of that to control the speed, but in direction we will use a deformer and mograph to do that. So now if you hit play, the field force will be pushing it out like we want. So let's increase the number of machines to like 500 once again, and also let's increase our time to maybe 600, right? So that particle keeps moving. And now let's come here into our simulation forces, and you can add the turbulence again. Let's increase it a bit more to like 200, and also the scale up something like this. And if we hit play, you can see we have turbulence going in crazy. Let's actually reduce the turbulence speed to maybe 120, right? And I think if we hit play, something like this. For now, let's assume we are cool with it. So let me go ahead and hide the field force. And like again, we don't want the turbulence to move in all over the place like initially. So within the turbulence, we cannot use another force. So if you come to the fields tab, we can actually create a cylinder field, right? Let's set it to minus Z. And now we want our turbulence to stay within, like the movement to stay within the cylinder, the shape of the cylinder. So let's make it a bit longer like this. And also make it a bit slimmer like that. Let's actually change the view so that you see something like this. Just like the cylinder, you can see. So if you stay within this particular shape, I think let's actually come here, front view. Should stay within this particular shape, something like this should be fine. All right, and let's open the remap. So I think something like this. So if I hit play, turbulence will be going crazy, but you make sure you stay within that particular radius, not going away. So if you want, you can actually even make the emitter smaller, maybe 20 by 20, so that we can also make the cylinder field a little bit smaller once again, right? And now you can see we generate our particles, and it all tries to stay within that radius of the cylinder and never go beyond it. And that's exactly what we want. So this basically giving our object, our particle, the speed and the turbulence and all of that. That's all we are using the forces for. Now to get it to follow the direction of a spline like we did in the first one, let's go and copy the spline. Again, I'll come edit, copy, and I'll come edit, paste, right? So you can see we have our spline in the scene. And with this one, we don't necessarily even have to get it to the tip where we want our object to be, like to start from. We can let it be anywhere. And now we will select, come into our mograph matrix and select the matrix, change the mode from grid to object mode. And the object we want to clone on is this emitter. So I'll drag and drop in the emitter, and you can see now we have matrices on the emitter. Right, let's select the matrix and make it a bit smaller. So I'll make it 0.5. 2, and select all of these S. Make sure this one is highlighted. Control Enter will affect all of them like that. So make X, Y, Z all 0.2, 0.2, 0.2. And now let's create a null object, put our matrix in it. And now let's come into our deformers and create a normal spline wrap. Drag and drop the spline wrap into the null, the same as the matrix. And now we want to wrap the matrix, like let it follow the path using the spline wrap. So now let's select the spline wrap, drag and drop into our spline, and you can see it's trying to do something, but it's not working. So all you have to do is to change the orientation to +Z, and you can see now our matrix is following the path. But right from frame 0, you can see it fills the path already. It doesn't start from the beginning like we want, and that's because if you select the spline wrap, the mode is set to fit to spline. So you try to fit it right from 0. So let's change it from fit to spline to keep length, and now you can see if I hit play, it starts from this point, and now it follows the spline. Now there are two ways that you can actually get it to end at the tip. So with the matrix, you can simply use effector. So I can select the plane effector, and I come to the parameters, make sure scale is checked, uniform scale, and I set it to -1. Right, and I'll use fields. In the fields, I'll change it to linear field. Right, so first of all, let's disable the spline wrap, and you can see this is our linear field. Let's also hide the emitter and see only the matrix. So you can see this is our linear field. Let's change it to -Z, or let's see +Z, and let's move it at the tip here. Right, can make it a bit closer. So we can use the plane effector to hide our matrix where we want it to end. So you can see ends here. So now if we come into our spline wrap, enable it, you can see because it's ending here within our spline wrap as well, it also ends there. So we can actually select this thing and move it somewhere here. You can see you can play around with it, something like that. If you think how we want it here, something like this is fine. And now to get it all to also come together at the tip like we did it initially, we can use the spline wrap to control it as well. So I can simply, let's all go ahead and hide this one, and also I don't like the cylinder. Let's hide this one. I don't even like the spline wrap showing in the scene. So you can see everything is following. And now, like we did, if you want it to sort of clamp it at the tip here together so that everything falls within the container that we use, like the cap, we can simply select the spline wrap, come down here to the size in the attributes, and down here spline size, not the size, the spline size. We can actually at the tip here start moving it like that, dragging it down, and you can see it makes, when it gets here, it sort of clamps them together, so everything will have that shape. So everything will be flowing, and when it gets here, it begins to come together. So you can use this to do, or we can use the same technique that we did in initial, use the forces to sort of attract it together. So this is basically how we use these two different techniques to create a similar object, which is particles flowing at the tip of on a path, basically. Right, now to render this, I mean, let me quickly show how you render this. I actually used Arnold to render this, but also you can use Cinema 4D. So if I right click on the matrix, it's as simple as right clicking on the matrix, come to render task, and I add redshift objects, and you can see it recognizes the matrix as particles. So let's change the mode from disable to sphere instance, or any of them, or you can use your own object, custom object. So but for now, let's use sphere instance, right? And now if you come into our render redshift render view, you should be able to see this. If I hit render, you can see we have our particles like showing in our scene, right? And if I select the redshift tag, you can actually increase the size here. See, it's bigger, or we can actually go into the matrix and make it bigger here, and it will actually reflect with the redshift tag. That's how it works. But so let's select the redshift and bring it back to 1, something like this. So this is how you use redshift to render this. Now in Arnold, now after you've added this, to add materials, you can simply create a normal redshift material, which you can create here, and just apply it to it, and it should work fine, right? Add colors and all of reflections to it. So this is how you use Redshift to render. Now with Arnold, unfortunately, Arnold doesn't recognize the matrix object as particles. So when you use if I right click extension semaphore C4D to a anode perimeter, it doesn't actually, if I click, you can see, and I select, it doesn't see the matrix as particles. So if you want to use the anode perimeter, then you have to actually put it on the emitter itself. And in this scene, in this scenario where the emitter itself is actually not following the path, is this curve, it wouldn't work. So it will work for this particular scene where we are using only the forces. But in this scene, we want to render the matrix itself, right? So it means we have to get it on the matrix. And to actually get the matrices to render, we have to use a different tag, which is right click, come to the extension C42A tags. And now we will use the anode mesh particles. And now if you select the mesh particles, you can see now it sees it as particles. So now it's giving us a sphere like instance, right? And the same thing, we can actually use shapes, our own custom objects or quads, which is basically cubes or points as well. So now to render, let's go into the anode IPR, right? And with anode, you will need light in the scene to actually see what's going on. So let me quickly and with anode 2, when you select, let's select the matrix, the mesh particle mesh tag, and make sure the radius is set very low, so 0.00, maybe 5, something like this, because it will be very huge in the scene if I should render. So now if I come to the anode light, and let's add anode sky, you can see our particles are sort of showing. Let's change to physical sky or something. You can see our particles are showing it. I don't want it to see in the camera. Now you can see our particles are now showing, and you can go ahead and create our anode material standard surface as well, and apply it into our matrix, where we can add colors and all of those things in here. So if I select it, I can change the color to red and all of that. So you can see this is basically how you create this particular scene. I'll actually show how you actually mesh this particular scene, or use this same formula or technique to create a liquid, you know, move following a path or something of that sort in the next video. So stay tuned and watch out for the next video. I hope this video was useful and you've learned a trick or two in this particular video. Thank you for watching, and I'll see you in the next one.